we are looking at functions and their limits, and it makes sense to start with piecewise functions because we really want to know what happens where these two different functions have their sort of juncture, their meeting point. If you look up here, we're really asking about x approaching -4, but from below. That little minus sign there is very significant. From below, that means only 1/2 of these really is relevant to us, and that's where x is below less than -4. So it's saying, what is the limit as this approaches -4? And so I can sub in -4, squaring it. That gives me 16. -10 plus 16 gives me 6. Okay? But there's different forms of this problem. If that little minus sign was not there, then the two parts would need to agree. And so I would plug in my -4 there, and I'd get -8 plus 7 is not 6. They do not agree, so I would hit the does not exist, and that would be my answer. If it was from above, I would use only that other limit there. But this, I believe, is correct, so we're going to go. I like the way they show the solution, and then they kind of animate the piecewise function as it approaches from the left. All right, so moving along, I've got one on rational functions. So these, you just need to factor carefully. I think there is no way for me to write on this, so I'm going to just try to talk my way through it. It's a little bit hard without being able to write and cancel and things like that, but if you look at the top, it's factors. You want to factor this to be x minus 7, and x plus 1. So remember that x plus 1. See that 7 down there? If I sub it in, I will get a 0 in the top. If I sub in 7 down here, I will get a 0 in the bottom. This is an indeterminate form of 0 over 0, and so I need to have some canceling help me out. If I get 0 over a number, then I would type in the answer of 0. If I get a number over 0 in the bottom, like if this did not result in 0 in the top, I would then have something over 0, and I would hit the do not exist, okay? Because asymptote, approaching infinity. We sometimes will write infinity, but it really is just our way of representing like why the limit does not exist. But in this case, I have 0 over 0, so I need to factor. If I factor out a -2, then my x minus 7s will cancel. I'll have a -2 down below. I'll have an x plus 1 up above. Sub in 1, I get 8. 8 over -2 is -4. Fingers crossed, I will submit and hope for the green check mark of fame. There it is, showing exactly what I was talking about. And there is the limit at that removable discontinuity. Okay, so take a moment to look through, pause it if you need, but that's the math of that. Moving along, I go to radical expressions. Okay, this is where we're going to multiply by a conjugate. You want to maybe quickly verify it's the indeterminate form. 4 goes in, I get 0 in the top, 4 goes in, and I get 0 in the bottom. So I'm going to multiply by 2 plus my radical, top and bottom, multiplying by 1 in the form of 2 with always the opposite sign there, plus the radical. When I FOIL that out, I'll get 4, and then when I multiply radical x times radical x, I'll get x, and it's going to be a minus because a minus times the plus over here, and of course the middle bits, the o and the I parts when you FOIL will cancel out. So just remember that the denominator is 4 minus x. Oh, what a coincidence. That's what it is up above. So it'll cancel up above and down below. The only thing that's left up above is the conjugate half in the numerator. So that would be what? 2 plus radical x. When I sub in 2, I get 2 plus 2 is 4. Okay, so again, it'll show the work here, and you can see, oh, they have two methods. I like that. Method 1 is by the conjugate. Method 2 is factoring it. Oh, clever. Of course, you can factor it into the difference of two squares. We don't often think of that because it's just not as natural when there's an x and not like an obvious squared term. Okay, so I like that the way they show those solutions. I'm going to go back. I'm in the home stretch here. Complicated fractions. Again, it's tricky without being able to write on this easily, but if I verify 9 minus 9 is 0, plug in 9 down below, and that's 18 divided by what is that, 12. That is 3 over 2. Those would give me the 0 over 0 indeterminate form. So I just need to clean up these fractions. They can take different form. I'm going to clean up this denominator, and then likely it will cancel with the numerator. So if you know how to find a common denominator, you just multiply diagonally. So my numerator here will be 3x plus 9. When I multiply diagonally here, it'll be minus then 2x plus 18. And down in the denominator, it's 2x plus 6. Up here, if you recall, if you write it down, you can pause and do that. You're going to have 3x minus 2x. That gives me x. Then I would have 9 minus 18, which would be negative 9. So this numerator in this lower fraction is x minus 9. It cancels with that, and it leaves me then with this denominator here in the numerator. I'm going to flip the fraction when I'm dividing, and so I will then have just 2x plus 6 in that numerator. When I sub in 9, 2x, 2 times 9 is 18. 18 plus 6 is 24. If I get this wrong, it's just because I'm doing it here without the advantage of a pencil to write down. Fingers crossed, and I got it. Yay. But this is what it is that I was talking you through, so you can see in detail how they did it. Oh, a little bit differently. Yeah, a little bit differently. I just cleaned up the fraction. So they chose to multiply to get common denominator differently. Okay, 2 ways to do it. Maybe they show 2 ways? Nope, they don't. All right, well, I'm going to stop. Good luck. You'll make a few mistakes, but you can learn from them by checking out those solutions. Good luck.